We were talking about this coefficient on the discharge. So, coefficient of discharge is defined as the ratio between the accurate and the ideal discharge. So, CD is equal to CC multiplied CV. They assume the discharge at the vena contractor to the Q, so Q is equal to ACC multiplied V2 is equal to CC multiplied AG multiplied CV multiplied square root of 2AG. So CC CV AC square root of 2AG minus CD AC square root of 2GH. So therefore the accurate discharge through the orifice is given by Q equal to CD AD and multiplied with square root of 2AG. So coefficient of discharge for the sun or the dye, you can see in the diagram. That's what a coefficient of discharge is. Coefficient of discharge is below you imagine 12 years old. To take a season season moon, no, to Bioria season moon, Elohan, a coefficient of discharge. CD go to CC multiply, CV so you imagine 12 years. Hello, Vina contract to choose rate, no, a clear Majida Kama, you go to ACC multiply, V2 minus CC, AC multiply CV. Multiply square root of 2AG Yame CC CV AC square root of 2GA minus CD AC square root of 2GA Yama today. The Yamu Tegeran Twala, the Yitro and the Tripola, the Gera, the discharge of Q equal to CD AC square root of 2AG, so you imagine it, Pobialu Yama today. Equation that you can see that a different kind of discharge. CD equal to 0.61, CD equal to 1, CD equal to 0.61, and CD equal to 0.5. So you can see how the discharge will be coming. Alors, CD double multiplier below Ponga, he tried out popular CD 0.61, 1.5 at our multiplier. No, Duma, he blew Trala popular. As you go to CD AC square root of 280 and you imagine a CD double multiplier, the year blew Trala, Poma popular. See, there's a kind of hydraulic equipment. There will be a venturimeter, orifice and the flow nozzle. You can see the diagram of venturimeter, orifice and flow nozzle. The Poma popular hydraulic but the Kriya, venturimeter, orifice meter, flow nozzle, Pomo, popular. Then we will solve this problem. Consider a fluid with a density 800 kilogram per meter cube. This fluid is placed in the 5 millimeter jet between two parallel plates. Top plate is moved with a constant velocity 0.25 meter per second over the fixed bottom plate. It is found that the top plate experience a force of the 0.125 Newton per meter square. Determine the kinetics of viscosity of the fluids. The same fluids are flowing in the pipe. The pipe diameter is 200 millimeter. A pilot tube with the external manometer is connected to the pipe. The manometer fluid is the water. The height difference between the water levels in the two legs is 33 millimeter. Calculate the volumetrics are flowing in the pipe. Also, calculate the real numbers of the pipe flow. And not who are all to do we see a mass when do a baby 800 kilogram per meter to see it. And a year no to do a pie play beyond the Puja, no, to Manga millimeter, I wish they play beyond the Puja, tell like that. Tell you what, take by play Piago, no, gave it 25 meter per second. No, you shall need it. You shall need a the team I see there play Piadi 0.125 Newton per meter square, Piao Kane. At the Yamro, Amos way, no, the kinetics of viscosity of fluid. I mean, we Sitamu, Prama Pede. And now to the Ajaro, Eddie, a year away, a year, by them at Channel Season. Now, by a chain 200 millimeter, she there, Peter June, not for. It's a manometer, Tale the Kamasway, Eddie, manometer, Lemashi, she did it. At all, Eddie, no, the manometer, no, let down the Puja, but she down the Puja, I know Pujama, she did, no. I remember the Chana Moody, 33 millimeter today. And also, you do Badram, by the mass, see it, a year, 2 years, you know, Doyame. I mean, I don't fight them out here. I don't know about them. We have to calculate the kinematics of viscosity, so flow configuration described in the equation. So that in this case, Newton's law on the fluid shear stress can be calculated. Tau equal to F by A, so it's mu multiplied du by dy. In this case, mu is a velocity, du by dy is a velocity gradient. So this equation we write down fast. And now we have to do something kinematics of velocity. Now the usual is no theta move. Now to have a pit. Now the imagine ruler a way the machine short fluid shear stress Newton near Maya Popiame, Pro imagine Yeme, Tau equal to FIA equal to mu du by dy, so imagine Yeme. Mu as a velocity pit, mu as a theta move, no pit, du by dy garo, the velocity gradient, no more, and then Piaule move, no, Piaule move, no, not pit, and our Pramani does in Sabi Yema pit. We can write down the equation of velocity gradient can be written. So du by dy equal to du by dy is a u1 minus u0 divided by dy. And therefore the tau equal to FIA is equal to mu multiply u1 minus u0 by dy. So in this case FIA is equal to 0.125 Newton meter square. So u1 is 0.25 meter per second. So two equation we write fast. Now you might say dy by du by dy and imagine du by dy and also u1 minus u0 dy that's same. So tau also F by A so mu multiply u1 minus u0 by dy so imagine a problem. So FIA is 0.125 Newton per meter squareဖြစ်ပြီးတော့ u1 is 0.25 meter per second အဲ့ဒါလေးကိုစာပြီးရေးပါ Write down the equations are FIA is equal to 0.125 Newton per meter square, u1 is 0.25 meter per second, u0 is 0, and dy is 5 millimeter. So by rearranging the equation, mu equal to FIA multiply dy by u1. So substituting the value, the mu equal to 0.125 multiply 5 divided by 0.25, so you got 2 by 5 multiply 10 power minus 3 Pascal per second. And also we write down the kinematics of velocity. V equal to mu by rho. So 2 by 5 multiplied 10 power minus 3 divided by 800. So you got there 3 by 125 multiplied 10 power minus 6 meter square by second. So also we need to calculate the volumetrics of flow rate. So in this case, a pipe diameter d is going to 200 millimeter. So the flow rate Q is going to pi d square by 4 multiplied u. The u is the average velocity, so you substitute the average velocity, you will calculate the volumetrics of flow rate. So substitute the FIA as 0.125 Newton per meter square, u1 is 0.25 meter per second, u0 is 0 ဖြစ်တယ် dy is 5 millimeter ဖြစ်တယ် အဲ့တော့ညီမချင်းကိုပြန်ပြီးရေးတဲ့အခါမှာဆိုရင် mu equal to FIA multiply dy by u1 ဆိုရင်ညီမချင်းရမယ် အဲ့တော့တမိုးတွေအစားထည့်ခြင်းအပြင် mu equal to 0.125 multiply 5 divided by 0.25 ဆိုရင် 2 by 5 multiply 10 power minus 3 Pascal per second ဆိုတာရမှာဖြစ်တယ် အဲ့ဒီမှာဆိုရင်ရွေးရှားနေတဲ့စီးထားမှု kinematics of velocity ကတော့ v equal to mu by rho 2 by 5 multiply 10 power minus 3 divided by 800 ဆိုရင် 3 by 125 multiply 10 power minus 6 meter square per second ကိုရမှာဖြစ်တယ် တူတယ်လိုက်စီးဆင်းမှု flow အဲ့ဒါတွက်မယ်ဆိုရင်တော့ပထမအဆုံးဒီပိုက်ရဲ့အချင်းကိုတွက်ရမှာဖြစ်တယ်ပိုက်ရဲ့အချင်း d 200 mm ဖြစ်တယ်ဒါလို့စီးဆင်းမှုနှုန်း q ဒီ pi d square by 4 multiply u အဲ့ဒီကဆိုရင် u ဟာဆိုရင်စီးဆင်းတဲ့အလျင်ဖြစ်တယ်အဲ့ဒီတမိုးထည့်ပြီးစီးဆင်းတဲ့ကြမ်းမြအလျင်ဖြစ်တယ်အဲ့ဒီတမိုးထည့်ပြီးတော့မှစီးဆင်းမှုနှုန်း flow rate u ကိုတွက်ရမှာဖြစ်တယ် This equation is that we can also you see there will be the u is the average velocity and u has to be determined using the bit or user information. So we have to utilize the Bernoulli equation. အဲ့ဒီမှာဆိုရင် u ဟာဆိုရင်ပြင်းပြအရင်ဖြစ်တယ်အဲ့တော့ u တန်ဖိုးကိုမှ bit or u ရဲ့အချက်လက်ကိုမူတည်ပြီးတော့မှတွက်ရမှာဖြစ်တယ်အဲ့တော့ Bernoulli equation ကို bit or u မှာအသုံးပြုမယ် This diagram you see that a p dot u equation. So p dot u is also the dimension h1 you see over here. So p1 by rho g plus v1 square by 2g equal to p0 by rho g. So therefore equal to v1 square equal to 2 multiply and v0 minus rho p1 divided by v. So that equation you can get. Now, the more popular p dot u is set up with Pong and Teddy Amashi at Dina. She did p1 by rho g equal to plus p1 square by 2g as well p0 by rho g and v1 square as well 2 multiply p0 minus v1 by rho so that imagine it not too much. For that we use the equations of pv is equal to p0 minus a0 multiplied rho g p0 is equal to pa is equal to p1 minus h1 multiplied rho g. So from this equation A and B, so we can see PB minus PA equal to P0 minus P1 plus H1 rho G minus H0 rho G. So that H rho WG is equal to P0 minus P1 plus H rho G. So P0 minus P1 equal to H rho WG multiply 1 minus rho divided by rho W. And therefore then we calculate, so V1 is equal to square root of 2AG multiply by rho W by P minus 1. And then V1 is equal to square root of 2 multiply 0.033 multiply 0.81 multiplying 1000 divided by 800 minus 1. So you got 0.4 meter per second. And now the imagine step B the comma with PBR so P0 minus A0 P rho G and PR P1 minus H1 rho G and and now A and B and go shine like the comma so PB minus BAD P0 minus P1 plus H1 rho G minus A0 rho G yame and now H rho WG so P0 minus P1 plus H rho G when imagine yame and also P0 minus P1 the H rho WG multiply 1 minus rho divided by rho W so yame. Yeah, section like the comma so P1 the square root of 2AG multiply and rho W divided by rho minus 1 so and imagine you type your term only started the comma so V1 the square root of 2 multiply 0.033 multiply 9.81 multiply 1000 divided by 800 minus 1 so 0.4 meter per second yama. Says the type of the flow control. When using the pipe in the most liquid between the process vessel, flow rate is to be controlled. So in this case, flow rates have to be done. The throttling. Throttling can be true. It is by changing the pressure drop, the sharpness of the car, it can be changed. The pressure drop increase, the steepness increase. So this is achieved by the opening or closing of valve downstream of the pump. Pump is used to the control of flow rate called the throttle valve. And that's what a pipe. 点嘛是的医疗喏，天桥啊嘛，其实天桥过来嘛，所以呢，说操练做把那些边个要路比咯，啊，天桥下去的，然后法务都没有天桥的，法务都没有咯，然后学校部还是有天桥经理的操练把路好的。I see that you can see the throttling. So when you see the throttling, depending on the kind of the valve, how the valve is fully open or the half closed or the one-fourth closed, how the flow rate will be changed. You can see that those are characteristic diagram. Now, when we talk throttling, but the program is today, and the valve program maybe a valve appear point at the web channel, or label the point at comma swing to see the no the block sheet struggle, throttling valve, bone sweat that do a match. Do it now a chain bone sweat. So you see that a variation on the pump speed. When the flow rate change, has changed, how will be the pump speed will be changed, you can see that this diagram. And that's what the pump machine change, I found them head now season move down LO season they do it. Now, pan ye, I think you move the view one, labor move, no move the view ma. Season move the, now two are here, head the blue, down it, I hope, Boma Professor, do you